Yo, what's up, everybody? Welcome back. Today we are working on a collaborative Rube Goldberg machine. So back when I was a kid, I grew up in Vancouver, Canada, and we went to this place, Science World, and outside Science World, there was this like super sick like ball machine where it was outside. You would just go to Science World, and instead of like going in and paying money and looking at science, you would just stand outside this like cage, and you would watch this machine where these balls would just like roll around, and they would go through this like whole contraption, and they were like conveyor belts, and then they would like bring them up from the bottom top, and you would like stand outside and like what you would like try to follow one individual ball, etc., etc. It was like super fun. Yes, and according to YouTube, you can also meet most beautiful ladies at Walmart. But the point here is that this ball machine was like super fun, and like growing up in like the 90s, my sister sent me this video yesterday. She's just like, we just like looked at stuff, and he's like, yeah, we just loved staring at stuff. And so I've always like kind of like liked this idea, and I thought it would be kind of fun to try to make like a version of this thing where maybe it's like collaborative and online in some way, right? So what I'm imagining is I'm imagining that there's like some sort of like 2D grid of like chambers. And in these chambers, we are going to have like some ball, and he's going to be like spawned somewhere, and he's going to like follow some trajectory, right? So maybe this chamber, all it is like a ramp, right? And so the ball will like kind of go down here. And what I'm kind of thinking is we could make like complex chambers through some form of like plugin system where each chamber is defined by code, right? And if user submittable code. So I'm thinking that we take some sort of like WebAssembly modules that people write, they can upload them to some server somewhere that's running this simulation, and it will like slot them into some spot, right? And so you could do all sorts of stuff, right? I'm imagining like maybe one of the chambers has like a cannon in it, and like the ball goes into the cannon and then it fires it out. It goes and then in this chamber maybe there's like some sort of like heavy mass in here, and instead of following normal gravity rules, the ball will like come in here and it'll like orbit this thing and get like slingshot shot out the top or something. And then maybe like in this chamber there's like a pool of water, and every once in a while it like gets flushed out of like some siphon, and the balls kind of like eject down with it, all sorts of things. I'm just thinking like something like pretty dynamic, pretty where like the rules are not super well defined, but like constrained enough that there's some sort of cohesion between the whole thing. That's kind of what I'm thinking. And so I don't really know how that's going to turn out. I have this like really cloudy idea of like what it's going to look like in my head, right? Like chambers, server running simulation long term, right? I kind of like the idea of like seeing how the balls, like maybe some chamber like eats balls a little bit, right? And doesn't let them out very fast. And maybe over time, like all the balls accumulate in one chamber, and you only see that after the simulation runs for a long time. So I want the simulation to be running for a long time. And so I'm kind of thinking cloudy ideas. I don't know like how ideas form in your guys' head, but for me, what happens is I end up with this like really fuzzy idea where I have like this like cloud in my head, and I kind of see like a little bit of a corner of something poking up here, and it's like WASM, right? And like I have like some other corner over here, and it's like physics, and like some other corner here that's like server, right? And like inside, I don't really know how these things are like fully going to look, but I kind of know that I want these things to happen. And so I'm thinking today the plan is some form of initial setup. And I think that since I know that I'm going to want this running somewhere on a server, especially because that's going to be running the simulation, because I don't really trust, even though like WASMs should be like relatively sandboxed, I don't trust it enough that I'd be willing to run strangers WASM code on my computer in my house. Oh, but I would trust enough to run on some fucking VPS somewhere that I don't give a shit about, right? So I'm kind of thinking, what makes sense to start off with is we know that we're gonna have like server, we know we're gonna have like WASM, and we know we're gonna have like client, and we know we're gonna have balls, right? That's kind of like the pieces that I know. And so what I'm thinking is today I want to kind of start with making a server that like controls some form of like ball position, as well as some sort of like rendering of those ball position in some client, and then I want to start flushing out like the beginnings of like a physics system. I think that that's like the basis for what this whole thing will do. And then later we can kind of say, okay, now that we have like this basic thing where we have like a ball that can roll downhill, like then we can start thinking about how are we going to interface with that thing, right? So I don't know, WASM modules, like they might end up defining like each individual pixel color. That seems possible, right? Because then you can draw really complex things. They might handle their own physics, right? Because like say I want to do something like make like a little portal thing, right? Where I have like ball goes in one side and shoots out another. Like we're gonna have to have some sort of like heavy interaction with the physics engine. But you know, if I just want to define like a room that's just like a bunch of pegs and the ball like falls down these pegs and jumps around, we want like some form of consistency between different modules, right? So it's like if everybody implements their own physics system, one, like the size of these modules is going to get like really large, and two, there won't be like a feeling that it's like one cohesive thing. So I kind of think that we're going to want like some form of physics system that is consistent, but with the ability to override it. Like if you want like low gravity, you want like buoyancy, you want like one-way surfaces, like all of this type of thing. Maybe we were going to like want something like that, you know? So I think I want to start out by fleshing out like the beginnings of a physics system, and then once we have that, then we'll kind of know where we have to tune it in order for it to interact with this like plugin system later. That's the plan for the day. So I think we'll start by making like a little HTTP server that like runs some sort of physics simulation in it. We're gonna just start by like giving a ball position to some client. Right now, I think today we're going to look at probably an HTML canvas to draw that stuff. There's no real way, there's no guarantee that we're going to keep using an HTML canvas as our drawing framework later, but like for now, it makes sense to start with those two things separated because we know we're going to want them separated later. Then we're going to do some sort of like physics, so like apply some gravity, handle some sort of collision, maybe like put the collision on an angle or something, and make sure that we can like handle that stuff okay. I've never like worked with like physics systems before, so you might see me doing some like really dumb shit, and that's part of the fun. That's part of the process. So let's just kind of get moving and grooving. That's the plan. That's the plan. Okay, long intro, but I think it's fun to set up the project. Have a standard protocol for ball transfers? No. I think that probably, I mean, since we're talking, since you asked, I think probably what's going to end up happening is we're going to have some sort of like array of like ball positions or like ball structures, right? And we're going to have like, you know, ball 1, ball 4, right? And each module is probably going to like act on these balls in some way. And they're going to, you know, they might, I haven't decided yet. Maybe they will say, hey, here are some surfaces that the balls can hit. Maybe they'll say, here are some forces that we're applying to the balls. Maybe they'll say something else completely different. I don't know. We should start with a physics system, see what our physics system supports, then we can design the interface after, if that makes sense. Okay, so I've got a new folder. I called it Ball Machine, and I copied our shell.nix from our other Zig projects. Differences today is that I upgraded my NixOS version, so I don't have to pull in Zig 0.12 from Unstable anymore. It's like actually packaged, so that's kind of nice. I don't have need that hack anymore. And let's just get moving. So I guess we are going to have to make some Zig application that spawns some HTTP server. And then we'll kind of just move on from there. So pub function main void probably returns an error. He's going to use a standard library. And the standard library has an HTTP server in it, I think. So we should just be able to do like std HTTP server. How does this thing work? Receive head. Okay, how do like in it. So I initialize this thing with a connection, where a connection is what looks to be like an open socket. So if I am a listener, I accept connections from my TCP server. There's a whole bunch of physics engine that do collisions in Rust because of it. We're not sure about Zig though. I mean, what's the fun in using a library to do the whole point of, well, maybe not of this. The whole point of this like channel is to discover things, right? So like Pulling in a library to do that, boring. We can write our own physics system, and it will be worse than every other physics system and slower than every physics system. But it'll be ours, and we'll love it, and we'll call it our little baby. Okay, so this thing we have like a TCP server that we pass to our HTTP server. This TCP server, how do we like create this thing? There's no init. There's just accept for a server that already exists. So I guess we could just create a stream. This thing has an address associated with it though. Okay, I think I need real Zig docs. Real Zig docs, here we come. Zig standard library. I always Google standard library, and then it actually never gives me a link to the standard library. I always have to go here instead and then click on it. And then we want 0120. And then we're looking at what? Server. Stud net server. How the fuck do we make like stud net? TCP connect to address, TCP connect to host. I guess like probably we're going to need some sort of address listen. Address listen creates a server, and so then all we have to do is make an address from our own IP, I guess. So we're gonna do like stud net address parse IP4, not parse IP4, init IP4. Yes, because we can just say that for now, we're going to look at 127.0.0.1 and on some port 8000 or something, who fucking cares. Const adder is equal to this. And then I think it said it was like adder listen with some options, but who gives a fuck? We can try this thing and say that we have some sort of like TCP server. And then I think that it was TCP server accept was the next thing. And then this gives us a connection, which I guess is one instance of a connection with one person. So what we would really normally want to do on like an HTTP server is like, you'd want to ensure that like you have multiple connections available at once. So you would probably either like I would probably stick this on like some sort of epoll event loop where I watch for incoming connections and then I service them through that. But like I'm only me right now. We can just work with ourselves. And so we'll just assume that we're going to do some sort of like loop where while true, we try to get a connection from our TCP server. Is it accept? Accept. And after we get a connection, that's when we can create our HTTP server. So it's stud HTTP server with this initialized with this connection. And it looks like they want a read buffer as well, which I think is just like somewhere for them to put intermediate data. So I think we just say like, hey, give you fucking 4K. Here's some fucking data. Do what you want with it. So here I think we pass in read buffer. And then we should be able to just like pub function receive head. The header bytes reference the read buffer, blah blah blah. Oh, but this will give us a request that we can work with. Perfect. That's what we want. We want a request. We want a request. Okay, so const rec is equal to HTTP server receive head. This is try, and then let's just stud debug print the request for now, because I feel like I don't really know how this is gonna what this does. I know we've had an HTTP server in Zig before, but I forget it already. It's been a minute. Okay, so unused local constant rec because I didn't log it. He doesn't like that net server is constant, so this has to be var. What else doesn't it like? It doesn't like this HTTP server is non-mutable. Makes sense. Okay, we're chilling. We're chilling. Run exe. Nope. Zig run source main. Okay. Chillin', chillin', chillin'. Which looks like it's doing something. And if we go to localhost 8000, we do have a request. There's a lot of 170s in that request. I don't know what that is, but oh, it's the read buffer. So it was full of uninitialized memory. And in Zig, when they with uninitialized memory is started with 170 if you're in safe mode, so that when you use uninitialized memory, it's like very clear to you that you just have like a bunch of A's or something. But it looks like they've like populated the buffer with some stuff. And how do we use this thing? What is in it? Okay. What is in this thing? We have a request. And what are we going to want to do with that request? We're going to want to serve some web page, probably, and serve some like ball position based off of. So we'll probably have like two endpoints. One that's like the index for the page, one that gets us the ball position, which means that we're gonna have to look at this request and figure out like where it's coming from. So I think that's head target, if I remember correctly. So maybe we look at rec. We log this as a string. And we look at rec head target, and let's run this again. He gets mad because we didn't properly clean up our sockets from before. Because I hit Control C, which just like kills the fucker. And instead of fixing that, which I would normally do, I think that this would just like say reuse port is equal to true. Blaze it, you know? We'll just overwrite the old port that hasn't been cleaned up by the system yet. No? Fuck. Addr use. Reuse address. Just force it. There you go, buddy. You can do it. Okay, so when we went there, we got like a slash, and if we go to like ball position, we get like another URL. Okay, so we can switch our behavior based off of that. I guess we are going to serve some sort of HTML. So let's kind of start there. Let's do source res index HTML doc type HTML or something. Is it which one of these is supposed to be uppercase? Maybe this one, doc type HTML, something like that. HTML, we have to close the tag. And we have some head. We don't really care what's in it. And we have some body. And then like in that body, we stick a div. We say, hello world. And we have to serve that somehow. So in main Zig, we have to do something like, so we want to look at the request, and we're going to want to see where's it coming from. So we're going to say parsed URL is some enum, and we're going to say that he has like, he can either be the index.html, or he can be ball pause. Is that how we want to do this? I guess like as this goes on, we're not going to want to like enumerate every single file that we might serve. So maybe serving like our endpoints like this makes sense, but everything else makes a little bit less sense. So maybe we will make this like I don't know, endpoints or something, and we actually don't need to do any of this right now. That's too much, too complicated. We can just do if the target is equal to, not equal to. We can't do equal to in this language because it's like a pointer that we need to compare the internals of. So we do std mem equal u8 of this thing to ball pause. If we do that, we're going to do one thing. But otherwise, we are just going to look in our like resource folder and try to serve that file. So let's do that. Pub function get resource. And he's going to take in some path. Yes. Yeah, that makes sense. And he's going to return. What's he going to do? I guess maybe he will serve that thing directly into the request response. So I think that this request, okay, here's what we'll do. We'll return a file or std io any reader here, maybe? I think that this thing might require some sort of like references, which kind of sucks. So maybe we'll just do file, std fs file. That seems reasonable for now. For now. And we will look in some folder. So for now, we'll just hard code it as source res. And we'll say dir is equal to std fs current working directory open dir this thing. Yeah. And then we will say dir, I guess this needs to be failable. And then we say open file. And we just take the path, but strip out the leading slash. So just like this. yeah, sure. Is video glitching or just for you? How bad is it? Is it just like a little bit of like shitty compression artifacts over the camera? Because that happens sometimes. It doesn't look too bad if I look in my left screen. I guess let me bump resolution. Let's see. That seems okay to me. Just hand wavy, looking for like 3 seconds. So I'm not too worried about it, but I'll keep an eye out. We'll keep an eye out. I played Valorant, probably need to reboot. Dude, that's crazy. Being like, my whole computer gets fucked every time I play a video game. That's really funny. Okay. Okay, what am I doing? So we are looking for this resource, so we'll say, const var f is equal to... Do I have to close directories? Like, does this have to get closed? Pub function close. Oh, interesting. It does. Okay. So here, I guess we say defer dir close. And then here we'll say this is get resource rec head target. This is failable, and then defer f close. And then we just need to copy the contents of the file into our request response. So I think it's a request respond streaming. And what goes into this respond streaming options? Send buffer, content length, respond options. Batch bytes before sending. Oh yeah, sure, okay. If it will use chunk transfer coding, if we don't give this, that's fine. And then respond options needs this stuff. But all of this is fine. None of this matters, I think. So I think the only thing we need to provide here is the send buffer. And here we'll just say send buffer. And the send buffer is just going to be a bunch of U8s again. Easy. Easy. Var response is equal to this. And then we just want to like copy all of the bytes from the file into this thing. So I think last time we did this, we used something that was like pump, linear FIFO pump. Pump data from a reader into a writer. This sounds like what we used. So we used a linear FIFO. Do we have to do it this way? I guess, yeah, I think this is the easiest way, right? Pump. Unless there was something in like IO. I don't think there was. I think that we had to use the linear FIFO last time. Even though I didn't like it. And I don't like it this time either. Bump, 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 bump. Yeah, I think that is what we did last time. So, linear FIFO. So we have to construct this thing. So stood. What is this? Where are we in here? FIFO. Linear FIFO. Was the pump thing directly on here? Like, did it need us to construct him first? Pump. Oh yeah, so he takes in self. Right. So we need to construct him. So he is a function that takes a type, which is U8, and then a buffer type, which is static, I guess. So I think we go like static is equal to 496. Give him a 4K to pump with. On a C or a Nix file, you would use send file. I guess I guess if your underlying file descriptor, yeah, I think you would, because that copies all the bytes from one file descriptor into another. But it does look like this is only defined in POSIX land here. So I think we will just do it this way. This is fine. This is fine. So here we need to initialize this thing like this. And then we just do FIFO pump from our F reader into the response writer or something. It's going to be something like this. I'm not sure this is perfect, but it's fine. We don't have a build system. Fine, we'll make one. We'll make one. Because I don't want to have to remember this. I don't want to have to type run exe over and over again. So you're taking a build. We take in a builder, which I think is like this. I think. And we return void. And then we say const standard library is equal to import stood. And we add an executable. And this executable has some options like a name, ball machine, and a root source file, which is relative path source main zig, like this. And he needs some like target and optimize, which needs to come from B standard target options. Boom. Const target is equal to this. Opt is equal to standard optimize option. And then we're almost there. We just get this executable out. And then we say build install artifact from this executable. Zig build. Could you make it auto-filled file on change? Yeah, but I don't really see a need to. I'm okay with just doing it by hand. Okay. Main zig. This is at line 33. No, line 4. So he doesn't like open dir. He probably requires some sort of like open arguments I don't give a fuck about. Open file required 2 arguments. So again, it's going to need some sort of like options I don't care about. He can't close this thing unless it's variable. So we do this. And respond streaming doesn't like that rec is constant. So we do that. Boom, boom, boom. Errors ignored on FIFO pump. So we do this. And we should be able to do zig build and zig out, boom, boom. Okay. So he should be running, and we should be able to go here. And he gets mad because the file is not found. But if we looked at index HTML, nothing's happening still, which is kind of interesting. Maybe because we have to finish this thing after we pump. Response. One of these things. End. This. Let's try that. There we go. Okay, so we got our little hello world. We're chilling. Okay. Okay. So if we get this wrong, instead of fucking crashing, we should probably do something a little more sane. So let's do like service request. Yeah, I think that's reasonable. And then we'll take in the let me think. Hub function handle connection. I guess probably makes more sense. Yeah, and he's gonna fail in some way. And this is gonna take in a connection, which is stood net connection. No. What is this thing called? This comes from stood net server connection. Of course. And we'll just kind of shove all of this shit in there. And then we'll just call handle connection. And if this errors, we'll just kind of log something. Failed to handle connection, and then we'll log the error. That way we don't fucking crash, which would be fucking annoying. And then in here, we probably have to, maybe we should do something like defer response end here instead of doing it down here. And is there anything else we need to like defer here? We defer file cleanup. Do we have to close the connection? Maybe. How do I end these things? D-init. So maybe here we just do defer connection D-init. And hopefully we're chilling. He doesn't like this because at 22, this guy can fail. So I guess we will just do this at the bottom. Fuck it. And he doesn't like D-init, but we just checked it. That function was there. We just looked. Did we not? No, this guy has no. Oh, oops. this is on the server. But we can just do like connection stream close. There. Maybe return it if it crashes. Yeah, I should, but I'm not going to at this moment in time, even though it's the right answer. Okay. Okay. So we have our like HTTP server, and now we just need to like stick a ball in here. So I guess maybe we'll do something like const ball is some structure, and he's going to have an X position and a Y position. Maybe he's gonna have like a size, but for now, maybe we, yeah, let's give him a size, radius. And does he need anything else? X, Y, radius, maybe like velocity, right, if he's gonna be moving. But for now, let's just, we're just gonna try to draw him on the screen. So X, Y, and radius is plenty good enough. And we're gonna make some function that is, maybe we don't need any functions on him right now. Maybe this is fine. So I guess maybe we're gonna have some ball. And he's gonna have X is equal to 0, Y is equal to 0, and R is equal to like 1. I guess we need to like define our coordinate space to pick these values reasonably. So let's say that like one chamber has a size of 1 in each direction. Or I guess like our chambers are probably going to be rectangular, right? Like that's just in my head, like a 16:9 thing makes sense because that's the size of my screen. So probably we're gonna do something like this distance is 1.0 and this distance is like something else. Sure. So a reasonable ball size for this would be like, I don't know, that big, maybe. So we'll make our radius like 0.1, and we will make our X position 0.5 and our Y position 0.2. Fuck it. And then do we want our coordinate, where do we want like 0 to be? We could either make 0 here, here, or here. In my head, this makes the most sense to me. The bottom of the screen is 0Y, and that way gravity can like move up for up and down for down. That feels reasonable to me. So let's do that. We'll say that we're like 0.5 into the screen, 0.3 above the ground, and our radius is 0.105 maybe. And sure, seems reasonable. Okay. So now one of the things that we might need to work with is the ball. So when they come in and they say, hey, I've got something, I have a ball that I can work with as well. And if they get their special super secret target, if rechead target is equal, not equal, we already said it was stood mem equal with some U8s, and it's equal to ball pause. Or maybe we'll just call it ball. Yeah, we'll call it ball. That seems more reasonable to me. Then we're going to do something else. So this is going to have like some sort of early return here. And it's going to be like stood. Let's like JSONify the ball structure. So there's some way, if I remember correctly, to like just convert any struct into JSON. I'm not going to see it from there. We're going to get into here, JSON. One of these many functions will allow us to just take some type and spit out some JSON. Stringify? Stringify any type. Writes the given value to a stood IO writer. Yeah, okay, cool. So here we're going to need some writer, which is going to be very similar to this. We're going to have our response streaming. We have some response, and we should just be able to say, hey, I want to stringify the ball with no options into response writer. Right? Try this. Is this failable? Surely it's failable. Yep. And then we end the response. Boom. And after that, we return early because we're not going through this like file handling path. Yeah, okay. Handle connection, blah, blah, blah. Okay, so that should be enough. So we should be able to go to here and go to ball. And we do get this, but it doesn't know it's JSON, which is annoying because we have to set our headers. We have to set our headers. So here, we have to say response. I think it's actually was in, I think we saw it in here. In our respond streaming options, we have respond options, and one of these is extra headers. So respond options. It was extra headers is going to be one of these, and we just have to make a HTTP header. So this is equals like this. And we need like fuck. Name value. Okay. So name, content type, maybe like this, content type. They use capitals, and our value is gonna be like what, text JSON, maybe? Application JSON? Text JSON? Application JSON is what somebody in chat is saying. And I will believe them blindly, because the consequences are very slim. Okay, he doesn't like this because he expected a slice and he found a pointer? Am I high? Oh, I am high. I need to do this. Boom. He is a member of an array, like one array element, not the array itself. Much better. Much better. That looks like JSON. Looks like JSON. Okay. This is probably actually suffering from the same problem, where we probably need to set the content type based off of the extension, is what I've done here before. So let's do, well, for now, we will just set the content type blindly to HTML, but eventually we're surely going to have some JavaScript, and that's going to happen very soon. But we'll sort that out in a second. Refresh, and we can look at the network. We got index, response. It's HTML now. Okay, sure. Okay. And okay, we have a ball. We are sending it over to the client, and now we can draw it. It's time to draw. Let's draw a ball. So now that problem where we are only sending it as HTML is immediately a problem because we need to send it as JavaScript as well. Or we could just inline the JavaScript in our HTML file and then not worry about it. That will be a bigger pain in the ass though, because all the syntax highlighting stuff gets fucked up. We might as well split it out. Okay, source, res, index.js. We're gonna have to do something here. Console log hello world, just so we can get something moving and grooving. In our index HTML, we're going to add a script, and he's going to have some sort of source that's like index.js, and that's probably good enough. So now if I run this guy again, we refresh, he does get index.js, but he thinks he's HTML, which is a pain, which probably means that, oh, he does log. Oh, okay. We'll just lie. If our browser allows us to lie, oh no, he's mad. Okay, fine. We'll fix it. Main zig. So I guess we will extract the extension of the file, I guess. And use that to determine the content type. So we'll say path to content type. And if std path, std mem ends with, how do I want to do this? const extensions is a enum. I like this probably. This feels best. One of the extensions is JavaScript. One of the extensions is HTML. You're right. There was a missing T. You are correct. So we need to like path. We want to like. So there's a couple of ways we could do this. We could try to convert the string into this enum and then parse it out, or we could just say for. It's like inline for, because we're iterating these things at compile time. Stood meta fields of extensions. Yes. We have some extension. Or I guess we'll call this field. And then we can just say stood mem ends with. If we end with the field name. Yep. If this is true, or if we don't end with, we just continue. Otherwise, we do end with, and we don't have to indent again. And we can just say field value. And depending on the value, enum const enum val is equal to enum from int field value. Here we say that this is an extensions. I guess saying extensions plural here feels stupid. You have a list of extensions, but each one is one extension. And we switch on the enum val. Boom. And that's it. Yep, we just say if it's JavaScript, we return application JavaScript, or no, text JavaScript, I feel like. Content types. MDN content types. JavaScript. No. Oh, I guess we can just surely there's some JavaScript on this website, right? Surely. Don't call me Shirley. Content type text JavaScript. Text JavaScript. And then if it's HTML, we go to text HTML. And I guess we need to return these things. And otherwise, we can fail, so we can just say fuck off, and we say return error unhandled or unimplemented. Unimplemented. Yeah, there we go. Which means that down here we can say this is path to content type from rec head target. Boom, boom, boom. Everyone's chilling. Probably. Maybe. Maybe not. Nope, he's mad. 12. Oh. Comp time control flow inside runtime block. Fuck off. Okay, so we can't do it this way. We have to do if this, then this. No continues allowed in inline fours, I guess. Surprising. But now he seems to be chilling. He's chilling. And if we go back to our website, we see that this is JSON. We see that he gets his JS as JS and his HTML as HTML. We're chilling. Everyone's happy. And we have executed some JavaScript. Everyone's happy. Okay. We did Canvas. I guess I kind of want some like auto-completion stuff too. Where did we do our last web dev stuff? QR code decoder? No, that doesn't sound right. Where did we do? I feel like we recently did Zig web client. Am I crazy? And in one of our shell nixes, we would have had like prettier and stuff. Was it this one? Oh, okay. Maybe it was this one. Yoinkies. Okay. Exit. Foreground. Exit. Next shell. And then hopefully everything just works. Hopefully we just have JavaScript autocomplete. Hopefully. Give him a sec. He's got to think. It's a hard life over here. Oh, he's got to download a bunch of stuff because I just updated. That's fun. I got to download all of Node just to run. I get that tools are written in the languages that they should be, that they're like for, but man, I'm not a huge Node.js fan. Okay, there we go. So it looks like we can do like, yeah, cool. Autocomplete is there. Much better. Okay, so we need an HTML canvas. Okay. We need some canvas. Boom. Is this what I want? Width 800 by 600. I don't give a fuck. And I guess let's just start by painting our canvas in one color or something to make sure that we know how it works. So we'll call this canvas. And in our JavaScript, what did I just do? There we go. Index JavaScript, we have, you're supposed to do everything after everything's ready, right? Document onload, window onload. I think it's something like this, right? Then you can do like async function init. I don't know what the fuck I'm doing. My JavaScript's shit. But we should be able to do like document get element by ID. Canvas. Okay, and how do I work with this thing? Get the element, get the context. And then I think that you can like trick. I can like trick this thing into giving me auto-completion on this if I say like type HTML canvas element here. Then is CTX resolved as well? Yeah, there we go. Nice. Nice. CTX rect fill rect. Yeah, okay. That sounds familiar. I think we have to say somewhere that we have like a color on the context. So we have to say like context. I can't remember. HTML canvas rect CTX fill style. That sounds right. That sounds right. We'll see an example on MDN. Fill style. Here we go. Yeah. And then we go from 0, 0 to canvas width, canvas height. Okay. Are we chilling? Wrong one. Also, our server's not running. Let's start a second shell so that we can run our server and update our JavaScript as we go. Give him a sec, he's thinking. It's a hard life over here. Zig, build, and run. Refresh. There we go. That's a green box for sure. That's definitely a green box. The green box felt really big, but I guess we were zoomed in a lot. That feels fine. Okay. Okay. Now what? We want to draw our ball. So I think you specify like an arc, and you can fill the arc. Boom, 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 boom. So, and then it's like CTX stroke at the end. They're gonna tell us. Give me a filled version. Here we go. CTX fill. Nice. Yeah, so I say, hey, I want to go at position. I guess we need the ball position, actually. So this is gonna be fetch ball. Ball response is this. Ball is ball response JSON, and we have to await that as well. And then do we have to do anything to parse this? I can never remember. I guess we'll see. I think that you can just do like ball X here. Let's see. Console log ball X. Does that give me something? X is not defined. Fuck. Console log ball. Oops, I don't have to compile anything. Yeah, this is just a ball. Oh, I see. It's not a dictionary. It's a ball.x like this. Much better. Okay. So, everything is scaled relative to width. So, ball x pixel position is ball x times canvas width. The y pixel position is the ball y times y relative to bottom. So this is like the y position times the width subtracted from the height. Yes. And then this we arc at ball y px, x px, sorry. Ball y px, ball r. I guess we need the radius to also be relative, so const ball r px is equal to ball radius times canvas width. So this is ball r px. We go from 0 to 2 times the math pi, like this. Nice. And then ctx fill. Yeah, let's see. Refresh. Fuck. Canvas. Can't access lexical declaration canvas before, because this needs to come up here. Boom. Then we get the ball. Then we do our stuff. Okay. We also probably want to set the fill style to be something other than green. Let's really fuck the red-green colorblind people. Oopsies. What did I just do? Refresh? Okay, not this one. Refresh. Okay. We have a ball that looks like it's approximately centered horizontally. That ball is very large, to be honest. So let's go back to main zig and kind of shrink it a little bit, and then let's try to make sure that like we know that our positioning is right. If we set the radius to like 0.01, then we set our y position to 0.01 and our x position to 0.01. We should see a full ball in the bottom left corner. That's what we should see. Refresh. Yep, okay. Looks like the math is all kind of right. I do want it to be a little bigger than that, though. A little bigger. So let's maybe do 05. What was that before? I already forgot. Maybe this should be runtime configurable. That'd be crazy. Okay. This should be 0.5, 0.3, and maybe 0.03 for radius. Okay, there we go. Cool. We sure drew a ball. Let's give it some gravity. Let's give it some gravity, not batteries. It doesn't need any batteries. Gravity will do all the work for us. Okay. So every frame, this ball has to move. So I guess, how do we want to handle that? We have one thread right now that's just servicing HTTP connections. And what's happening here is between connections, he's just waiting for the next one in this line here. So nothing will happen during that time. But we kind of want some sort of simulation running, probably at some like given tick rate, right? So I think normally what people do, I don't really know. I've never like done this before, but I know that like based off of what I've seen in video games and what I would assume, like physics systems kind of go in like steps. And say I have like a ball and he's trying to go like down towards the ground. I have like ground, right? What they normally do, I think, is this: they kind of like simulate the ball here, and then they simulate here, and then 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 it goes like into the ground, and they go like, oopsies, go up, please. No more ground. Don't go into the ground. Ground bad. And so I think that like the way these things usually work is just like collision detection with other things in the scene. So our ground is going to be modeled as like some sort of like really large rectangle, and we just basically say the ball is going to have some sort of downwards velocity. Well, it starts with no velocity. And every frame, every physics frame, right? Because we're not going to run physics at the same frame rate as rendering. Every physics frame, we're going to apply acceleration downwards. I guess we probably have to apply some sort of drag upwards as well. So change, like, adjust its speed and then apply its speed, and then check for collision. Seems reasonable. So all of this must live somewhere. Where do I want to where do I want it to live? I guess we're gonna want like some sort of like physics thread. Simulation thread. Do we want like a simulation structure? Probably. Yeah. No, we can just say like function step. So we're gonna step the simulation, and every step of the simulation, we're gonna step it by some delta, which is going to be, I don't know, some sort of forwards time delta. And then we'll just say like microseconds, nanoseconds, microseconds, milliseconds, microseconds, or nanoseconds. We have the choice. We might as well say nanoseconds and then just pick something big. Should simulation structures accept ball pointer? I think eventually what's going to happen is this is going to be, the simulation is going to store everything. Maybe. I don't know. We'll see. I'm kind of imagining this like just like a big like app class, right? Like this is like everything in my head right now. Maybe later we might split this into like physics, right? And he's going to like, but he wouldn't really have any state necessarily. All of the state to the physics engine would be external. And so he would just be like some function probably that's like step physics and like objects, and he's going to have like a bunch of objects in here. But for now, this is fine. We have a simulation that is working on one ball right now. Will the simulation be running on server side or client side? Server side. Plan is server side. I want the simulation to be running for forever over a long period of time because I like the idea of like seeing how the system behaves after a long period of time, right? If we run it on the client and I just start this thing every time we're working on it, we won't like get to see long-term effects. And I think that long-term effects would be kind of fun. So that's the plan, all on the server. Okay. So what's he going to do? He's going to apply gravity. Apply drag, move object, check for collision, and then like fix collisions. Okay. So we have a couple options here. One, the ball could just hold its velocity inside. Or we could do something like kind of like more game devy and have like balls, which is like one array of things, and velocities, which is another array of things. But for now, let's just stick the velocity in here. Velocity. And maybe we'll call this like a vec2d or something. Like this. Vec2 is a struct which has a x and a y. Boom. Okay. So he has some velocity. And what are we going to do? We're going to apply gravity. So delta, we'll call this delta nanoseconds. Velocity plus equals how does this work? Acceleration. So acceleration is in meters per second squared. And if we want to say how much has our speed changed, we have to multiply this by time to get from meters to seconds squared to seconds. So we take our acceleration. So gravity is 9.8 meters per second squared, approximately. And if we want to do this in integer space, we could convert this into seconds to nanoseconds. So this is, that's two, do I want to do this? Let's just do delta in float. We might hit floating point precision issues, but fuck it. We'll come back to that if it actually becomes a problem. So here we can just do gravity is 9.8 approximately. Do we want to get like crazy and pick better numbers? Gravity 9.832. Fine. And then we just say g times delta is applied to the velocity. This is going to be negative because we have down as negative, and so then we just say self ball velocity plus equals this. Boom. Simple. Simple. Then we have self as a simulation pointer. And then we apply drag. So at some point, this thing is gonna this is just gonna accelerate forever. But we know that when you drop something, eventually it starts to slow down. But that kind of means that like we have to apply some sort of like upwards force to it that is probably dependent on its speed. Probably. I was looking at this page earlier. Bouncing ball physics. I was like, what the fuck is going on? Like, what the fuck is going on when a ball is bouncing? And I think in here they mentioned drag. Yes. Which does look like it is some... Okay. 6 pi mu r v. So v is velocity. U is like density of the air. Pascal times seconds. Okay, what's r? R is the radius of the ball. Oh, okay, so this is... Oh, this is just how many fucking particles of air it's hitting, right? Right? You have like... 6 pi is some multiple of 2 pi. Right? So we have like ball, and then they're doing something that's like relative to this, right? So they've like some circle that's going through density of air times... Is S speed here? What is S? And U is 1.8 times 10 to the negative 5 Pascal. Is S seconds? I feel like it, maybe it's not. Depends on what, oh, yep, seconds? Okay, yeah. So they're kind of saying like air has some density of particles in it, pascals, and this is how much density we're hitting per time, I guess. This p value or rho, is this called rho? I can't remember. This is like not used anywhere directly in the formula. So this is just like literally just how many particles of air the ball is hitting, which is why velocity matters, I would guess. But I'm also just making this up, so don't fucking listen to me. I obviously have no idea what the fuck I'm talking about. But I mean, I think that this is basically saying we have some constant times RV is our drag. So const drag is... What do we want to call the drag constant? It's called U here. Drag constant. I don't know. Drag constant. Fuck it. I don't know. And what's like a reasonable value here? So we want something so that the maximum speed of the ball is going to be like... I guess we don't really have like a scale for how fast it's going to be moving. Like, but let's say we want it to go not that fast. So our screen is some size. We actually don't know the size of our screen in meters right now. I guess if we assume, we are assuming width of screen is 1 meter, right? Because that's kind of what we defined earlier. Then we can work in meters everywhere, which kind of makes things nice. We want probably like how fast can a ball fly through a screen? Max speed is like 1 meter per second. Maybe. That means no, go faster than that. 3 meters per second, 5 meters per second. Doesn't matter. We'll pick some max speed. Because this is the only thing that's affecting this right now, I think. Maybe not. I don't know. But let's say this is like 5. Then we need to basically make it so that this constant times drag times r times v, where our ball radius is 0.03, is equal to the acceleration. So we're going to have like d times 0.03 times v is equal to 9.382. Right? Is that kind of what we're saying? I think that's what we're saying. Which means that if we want our max speed to be 5, then we just do negative g divided by max speed divided by 0.03, which we're going to call ball radius. And then we can just write ball radius here. Approximately. I don't know. Fuck it. We'll see how it feels. We'll see how it feels. And then here we'll say ball radius. Which kind of means that maybe we don't even want to store this anywhere. If we have all of our balls the same size, then storing this as part of the ball, I don't know how much that makes sense. I don't know, it's fine. We'll leave it in there for now. For now, that might be a waste of memory. Okay. So then we say self ball velocity. I guess like the drag constant is relative to the direction that the ball is moving, right? So the ball, if it's going like, the ball is going like this way, right? Then our drag must be going this way, I think. So we kind of just, which means that it's kind of like just magnitude. Yeah. So we have like the magnitude of the velocity, ball, self ball velocity x times self ball velocity x plus self ball velocity y times self ball velocity y. This is like the speed squared. We just need to reduce this constant new speed squared. Can we do this in squared space? If we have like s prime is equal to s minus drag ish. If we have I think that it's easier if we square root this. Just kind of hand wavy. Fuck it. We don't need to get crazy. We don't need to get crazy. We will just square root this thing. We'll call this squared speed. Drag is proportional to v squared. Here it looks like it's proportional to v, assuming that v is velocity here. Oh, wait. It does say this down here, v squared. What the fuck? What is going on here? Why are these two functions different? Oh, because maybe u is Pascal seconds, which makes velocity... Oh. Depends on the re. Oh, if the Reynolds number is very low, but we don't know if the Reynolds number is very low. So we have to do this. Ah, okay. So we can't do it in squared space. Nice. Nice. Which means that we maybe got this wrong, but that's okay. That's fine. We might come back to this. This might be just absolute bullshit. Because I'm not really convinced this is right. At all. In fact, I'm pretty convinced it's wrong. Okay. So this is just going to be speed squared minus drag constant times speed squared or something. I don't know, man. Does that make sense? So we have like some sort of like amount that we want to reduce our speed by. Yeah, we have some amount that we want to reduce our speed by that's proportional to velocity squared. No, this is like speed diff is something like this. Drag constant times speed squared. And then we need to subtract our speed from that thing. Okay. So new speed is like the stood math squared of speed squared minus speed diff. And then we need to apply this in some direction. So I guess we have const current speed is this. Yup. New speed is the current speed minus the speed difference. And then we just have to say that the ball x velocity is multiplied equal to speed multiplier is the current speed, new speed over current speed. There we go. Yeah. That seems right. That seems right. By the way, your mic is peaking when you do loud hum. Oh, okay. Thank you. Thank you. That's good to know. I'll keep it a little farther. I should not scream directly into it. Should not scream directly into it. Okay. And then we just have to apply the velocity. So self ball x plus equals self ball velocity x, and the y plus equals y. Boom. We can start there. We can start there. Well, we'll just say if self ball y is less than 0, we'll just set ball y to 0. No. Self ball y is equal to the maximum of the radius of the ball. Yeah. And its current y position. Yeah. So we're basically saying it can't go lower than the radius of the ball. And that probably gives us something. So our simulation thread is going to maybe create a simulation. Except the simulation needs to be accessible from both the thread that's receiving, how do I say this? Fuck. It needs to be accessible from both the HTTP servicing thread and our simulation thread. So I guess we're going to make our simulation here in main. Like this. And our ball in the simulation is going to be like this. Vector 2 might be an easier right, because then you can do vol velocity plus ball velocity. Oh, interesting. What does that actually do? I assume that like packs two float 32s into a 64-bit register and then does something with that. Let's see. So that does feel kind of nice. Vectors. Groups of booleans, integers, floats, or pointers, which are operated on in parallel using SIMD instructions if possible. Oh, okay. Vector types are created with built-in function add vector. Vectors support the same built-in operators that are underlying base types. Nice. These operations are performed element-wise and return a vector of the same length. It is prohibited to use math operated on a mixture of scalars. Zig provides the splat built-in to easily convert from scalars to vectors. It supports reduce and array indexing syntax. Wow, that's kind of sick. And I guess it's kind of saying like it'll use SIMD if it can. But if you were to make something that's just like way too wide, maybe that's like just fine. Interesting. Interesting. It does seem like I should do that. That's just, but I'll keep that in the chamber for now, since I've already written this. Okay. So here we're going to say that our simulation takes in a point of the simulation. And I guess we need to lock a mutex here. Since our simulation is accessible from multiple threads, because we're going to be extracting the ball state, we'll just say self mutex lock and defer self mutex unlock. Okay. Okay, then we are going to spawn our thread. Spawn, I think. And he's going to look at the simulation, and we pass in the simulation. He's not going to like this, so maybe we'll call this simulation context. And here we'll call it CTX here. Then we don't have name collision. No name collision for us. Speed diff is a force which multiplied by delta. That sounds right. There's definitely supposed to be some sort of delta in here for sure. For sure. Let's think about this. Speed, drag constant times speed squared. So this, yeah, you're right. Speed, yeah, you're right. Because this is a force. Forces are meters per second squared. We're applying meters per second, so we have to multiply by delta. True. Maybe we'll call this run simulation as well. Okay. Okay. So then all we have to do is say that we have some amount of time. So const now is equal to, I guess this is a variable. Now is equal to stood instant time instant now. This is failable, so we say it will crash in that case. And then what are we gonna do? We're gonna say we have some loop. And while we are in the loop, we're gonna step the simulation. And then we're gonna sleep for some amount of time. So if we want to run the simulation at like 60 frames per second, then we sleep for 16 milliseconds. We need to step by some delta. So I guess we just start by sleeping for 16. This is milliseconds, so this is nanoseconds. Nano, micro, milli. Yep, okay. And then we say this is last. Now is equal to this again. And then we say that the delta S is now since last, and this is going to be in nanoseconds. So this is last float. Okay, const last ns is equal to, or delta ns is this. And then let's say this is a float 32, and then we can float from int and then we can do delta ns divided by 1e9. Boom. Okay. What the fuck is this? Now since last. And then at the end of this, we have to set last equal to now. And then we should actually be sleeping. That's fine. We can just do this. No, this. That's fine. Doesn't fucking matter. Doesn't matter. This won't be like perfectly 60 FPS, but I don't really want to deal with it. And then does it build? No. So ball. Wherever the fuck ball is here, this should be a simulation context ball, which means we should say simulation context mutex lock, defer simulation context mutex unlock. which is not great, but it's fine. I don't care for now. I guess I do care. Fine. Fine. We'll say const ball is equal to simulation context ball. Boom. Copy it out. Then we don't have to keep the mutex locked. We just go like this. Boom. Easy. Thread, he doesn't like that because we don't use it, so we have to do defer thread join. And then which means that like later we need to actually find some way to exit the thread, but we don't need to worry about that right now. Velocity is not initialized, so here we need to set the velocity to 0. I guess we can just say that the that's fine. We'll set it. We'll set it manually. Fuck it. What else? Simulation doesn't have the mutex set, so mutex is equal to stood thread mutex. Okay. He doesn't like that delta ns is instant? Oh, because I'm high. What the fuck? This is just delta ns over this. Boom. Okay, and then he doesn't like ball velocity times that thing, so when we're applying gravity, this is all in y. And sure, 107 doesn't like this. So can we just say comp time float? Or you just write 5.0 here. That fixes everything. Radius is not there because it's called R. So this is R here. And are we finally there? We are finally there. Let's run it. Okay. So the ball is at the bottom of the screen. But that is not helpful. That is not helpful. How do we want to do this? Okay, so we need to visualize like individual frames in some way. So our JavaScript should probably be like polling the position of the ball for now. Obviously, that's not how we'll do it later, but if we want to show some sort of progress, maybe we just run this in a loop. Boom. And then, oh, you can't do that though. You need to do something stupid. You need to do like async function draw ball, and we kind of pull all of this stuff. I guess we can just say set timeout, and then how do you do this? You say like JavaScript queue thing to run. How to set timeout. I know there's some way to do this. I just don't remember how. Request animation frame? That sounds right. This sounds like what I'm looking for. Request animation frame. Tells the browser you wish to perform an animation. Request the browser to call a user supplied callback function before the next hour. Okay. I don't know if I want this to do this every frame though. Oh, the timestamp is a decimal number. Wait, where's the timestamp? Where the fuck is timestamp coming from? He just has callback. Examples. Oh, because this tells us the timestamp. Yeah, we don't really want this. I want to like set interval. Somebody said. Yeah, I guess I could do this, where it's just gonna call this thing every once in a while. Is there not just like set timeout? I feel like this might be what I wanted actually. Yeah, just do this thing after some amount of time. So just do this after like a delay in milliseconds. So, I don't know. 33 milliseconds. I don't give a fuck. I don't give a fuck. Maybe we should do, that's fine. It's fine. Let's just see what happens. I can't connect, right? Okay. So build, refresh. Can we look at like, so he is spamming ball requests and the ball is never moving, which is fine. And let's maybe slow down the simulation. Just to see if we can see some form of progress. So main.zig, let us just kind of say that the delta is like smaller than it should be. Run it slow as fuck. But the ball is just stuck on the ground. So it's like immediately hitting the ground, which is kind of shitty. Let's just kind of like adjust gravity. Let's disable the drag stuff for now as well so that we can like just double check that we're not doing something like fucking stupid. Yeah, let's try that. Refresh, refresh, refresh. Okay, okay, wait, we did see something. We're not clearing the thing in between. So how do we want to handle that? We're not clearing. So in index JavaScript, we should clear the canvas. Which is just. Does this not clear the canvas? This? Every frame? Are we not? Why does this not clear everything? I feel like I'm missing something. Also, why did it stop working? I guess maybe what we'll do here is we'll reset. If the self ball y is less than 0, we will set the ball y to 0.3 again, and then self ball velocity x is equal to 0 and y is equal to 0. Start it over. That way we can see something happening at least. Okay, so why is it not fucking clearing? You could stream an actual video to the browser. Yeah, I was thinking about that, but I think that the bandwidth there would be way higher. I think there's a good chance that what ends up happening at the end of this is that I run the same WebAssembly modules in both the server and the client, but in the client we only use them for rendering, and on the server we use them for physics state as well. Something like that might end up being where this ends up. But it could also be that drawing stuff is cheap enough that we can just send the draw calls direct to the client. Or maybe you're right that like maybe encoding a video is the best way to do it. Maybe. We'll have to investigate all of those things. Am I high? Does this not clear the canvas? Clear HTML canvas. Clear rect. But I'm just surprised that the fill rect is not doing what I want it to do. It's confusing. But maybe it's fine. Zig build. Yeah, it's very clearly not. What the fuck? So here we do one iteration of the drawing. We say, hey, I want to get the current ball position, clear the fucking screen, draw the ball. Okay. So what the fuck is the problem? Like, canvas, HTML clear. No, are we like... There's no like exceptions happening, right? Right? No? Okay. HTML canvas not clearing. Rather than clearing the rectangle, you clear the canvas. Feels like I'm not doing anything like stupid. Is this not reloading my JavaScript or something? Clear rect is there. Because you are filling the rect after clearing it. But like the ball should be gone. Like that's what I'm like upset about. I'm fine with the canvas being green. Right, but like the fact that the ball is staying between frames, like what the fuck am I doing wrong here? I'm obviously doing something stupid. I just don't know what it is. MDN canvas clear rect example. Well, this is supposed to be easy. This is supposed to be easy. Draw yellow background. Fill the rectangle. Clear part of the canvas. This is the part of the canvas they clear. Okay, let's just comment this out. Just like, okay, nothing happening. Good. Like expected. Can we do like console log clearing, console log drawing ball? He is clearing between ball draws. Maybe move context out of init. No way. Really? I mean, I can see what you're saying. But that's crazy. Why can't I do this out here? Canvas is null. Oh, because this has to happen on load? Fine. 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 Draw. 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 And then here we have like, I guess this goes up here. And this comes here, and then this is null, and then we assign it here or something. Nope, still happening. Still happening. You should use request animation frame, but why? Like, I don't understand. I don't understand why this isn't doing what I want. Like, I have a canvas, I'm clearing the canvas. Like, okay, let's just do something. Let's do something else. We'll say, like, canvas, like, draw 2 or something. I just want to see what happens if I do draw 2. And then to this point, I just fucking slap the whole thing with green. Like, what happens if I do that? So that's doing what I expect, where I see a little red flicker, followed by green after. And then, like, yeah, I just don't get it. I don't get it. Let's draw it again. Yeah, what the fuck, man? I feel like I'm not doing anything crazy. It's so simple. It's like, draw the fucking full thing green, draw the ball. Oh! Fuck. Okay. So that's actually not too crazy. I like understand now. So we were drawing this fill command fills every arc that's been buffered. And if we don't say we're beginning a new path, we're buffering like 25 balls at the same time. Like every frame we're buffering a new ball, and that ball is staying in the buffer forever until the next begin path call. Oopies. Oopies. Cool. Okay, so now we have to understand, we had to like really fuck up our gravity and stuff, so I would prefer that our gravity stays like the correct acceleration. But then how do we make it so that like things feel like they're moving at the right rate? I guess we need to make it so that our entire world is bigger. The fill rect example had a begin path as well. Yeah, maybe. Except the whole world isn't turning red, so maybe not. There's a closed path here too. Maybe we should just be good citizens of the world and throw this in here as well. Fine. Fine, we will. I don't think we need to, but we'll just be good citizens. Sure, whatever. Okay. So in our main, I think that we had like heavily reduced time. And reduced gravity to make it feel this good. And why is that? If I drop a ball, it like moves some distance relatively quickly. But like to go like a meter, one is okay, so it's like just under a second to go around a meter. So here if we're applying 9.8 meters per second, which is real gravity, and we have a meter distance to travel. Oh, we only have 0.3 meters to travel. So that's like here. Yeah, that's really short. But again, it doesn't seem like it should be that bad. Can we run this again? How fast does this thing move? Yeah, something feels off here. It feels like it's moving way too quickly. Is this delta multiplied correctly? So here we change the y velocity by delta. Oh, hold on. We also have to change these by delta. Oopies. That's probably it. Because the distance change is also based off of, there we go, that feels way better. Yeah, that feels better. Let's move the ball a little bit up by default. So we'll say const ball start y is equal to 0.7. And then this is ball start y, and this over here is ball start y. Oops, we have this running twice. I'm just going to confuse the fuck out of this thing. Yeah, okay, that feels okay. That feels okay. I don't really actually want to deal with drag right now. That sounds complicated, and I don't know if we have like a good way to test that. Oh, I guess we do. We do. We could just not reset the velocity here when we reset. And we should see this thing just like increasing its speed forever. Which we do. It's just going like, it's going so fast now that we don't even see it moving. And so we just want to apply some drag. And just see what happens. Okay, so that drag is way too high. But it does look like it's approaching a constant speed. So we just have to like reduce the drag. So let's just do, what is this? This is negative 10. This is 10 over 5 over radius. So that's like 10 over 5 over 0.3. 0.03. So let's just, I guess we keep the ball radius and we just say this is 2 is what we had. And that's too high. So let's just drop this to like 0.5 or something. So speed diff is something like this. Sure. Let's try that. Still way too slow. Way too slow. Way too slow. That's good enough. Good enough. So we did like hand wavy drag tuned manually. And I'm not really positive. Not 100% sure that we applied the drag right, to be honest. But it also doesn't really matter. Maybe we go even slower or even faster. Yeah, that feels okay. Okay, now let's make it bounce. Let's make that baby bounce. So let's say we are going to bounce off ground. And that's probably all we'll get to today. Why did it stop? What's happening here? Network error when attempting to fetch. Oh, because we stopped the server. That would do it. It should stop moving if we stop the server. So I'm glad it stopped moving. That makes a lot of sense. Okay. So I think we're going to say that if the ball hits the ground, this is why I was reading this page the other day, actually. I was trying to figure out what the fuck happens. Why does the ball bounce? Because I'm a fucking idiot and I don't remember my like grade 11 physics, right? Like, because I know that when you draw your force diagrams, right, you have like ball go down at gravity, and then you're like it hits a thing, and then the floor pushes back up at gravity, right? Like the floor pushes back on the ball, that's why it doesn't move. That makes sense to me. But then it's like, why does the ball bounce, right? It hits ground, and then like now you're pushing up like almost double. Why the fuck is that? And like, yeah, this guy got it. Is when you look at this, he talks about the ball like deforms when it hits the ground, and then it's essentially acting like a spring shooting itself back up. And like how much it shoots back up is relative to like how like springy the thing is. But like overall, if it's like perfectly elastic, then you're kind of looking at like conservation of energy. So you have like is it 1/2 mv squared, I think? Kinetic energy. Formula. I think it's 1/2 mv squared. I think. Yeah. 1/2 mass times velocity squared. That just has to like be the same in and out of the system if you're perfectly elastic, right? So you'll have some energy loss to like heat and sound, I think. Is that where it goes? Heat and sound? Probably somewhere else. Ball bouncing Wikipedia. Where does it go? Impact. Sound and heat, yeah. Which is crazy. The ball only slows down. Like when you throw a ball at a wall and eventually it slows down, it's like it warmed up. That doesn't make sense. But sure, it loses some energy somehow. And so you just have to make sure that like your velocity squared is like the same before and after times some energy loss, right? So I think that like what happens is if you have like a ball coming at like a surface, then like the force of the floor is going to be normal to the ground, I think, right? So you just have to make sure that like you give it some upwards push, so that the velocity magnitude stays the same, right? So in this scenario, he's going, since the only way he can push is up, he's going to come back up at like approximately the same angle. You can cook a chicken by slapping it, no? Yes, the fire slaps it. Yeah. The fire is just like which I think makes sense, because if you were to have like a surface like this and you drop a ball on it, I guess you kind of expect the ball to come out like this way, kind of. So that probably lines up if there's like some force this way and it like is giving it the same speed. Like that all kind of like lines up ish in my head. I don't know what the fuck I'm talking about. It's been like, what, 15 years since I've taken any physics classes? Probably less than that, maybe like 10 years. But still, it's been a long time. I don't know what the fuck I'm doing. But I think this makes sense. So you apply some force relative to the normal of the ground, and that gets applied so that the velocities line up. So I guess that means that you have like, you have what? You have some direction, and then you apply some other vector, and you just need to make sure that the speeds stay the same after. That seems reasonable. Isn't angle of arrival equal angle of expulsion? Isn't that only if... Is that true? Maybe that makes more sense. That does sound right. Let's think about that. Let's think about that. That's how light works? Yeah, that makes more sense. Light doesn't really have mass, though. So, like, if I throw a ball... if I throw a ball down at the ground... do I expect it to come out, like, at a lower angle? Or do I expect it to kind of, like, come up at the same angle and then arc down because its speed is lower? That seems like an easier thing to model. Should be the same angle. That sounds right to me. I tricked myself when I was thinking about energy. But I guess if we just keep it at the same angle, we flip it over the normal direction of the ground, and then we reduce its speed a little bit to simulate energy loss. Sure, we'll try that. I'm not 100% sure that's right, but it sounds right. Now that you guys have said that, I'm like, that sounds more correct to me, and I would assume that you guys remember your physics better than I do, because I remember, like, jack shit. Okay. So, in our case, our only surface that we can hit is the ground, whose normal vector just goes up. So all we have to do is just, like, we only have to worry about y. Yeah, self ball y. How does this work? How does this work? So we're gonna be, like, some distance into the ground. And the amount of distance into the ground is how far it needs to push us back out. Over 2. So the y position is going to be it's self ball y over 2. Since you multiply acceleration by the small delta when applying it to the velocity, the acceleration required to keep the magnitude of velocity the same before and after a bounce would be ridiculously high. Usually you handle collisions with an instantaneous impulse instead of going through the normal acceleration velocity position machinery. Why does it matter? Oh, because, like, I'd have to apply such a large impulse. So you're kind of saying, like, you're saying it makes more sense to apply the velocity at the previous iteration's acceleration or something? See if it collides first. I'm not sure it matters, actually. I think, like, it doesn't seem like it's going to be that much different. Oh, but it does, because... Right. Because, like, if I have, like, a ball here, and within some delta, it would end up, like, here. I basically have to figure out, okay, well, how far would it have gone before hitting the ground? It would have stopped accelerating at that point. So there's, like, something about that. Basically applying an impulse to the velocity not to force the acceleration. Yeah. Wait, is that right? Let me think about that. So, what is impulse? Is a change in momentum of an object. Sure. What's the difference? Why are you saying... So you're saying that I want to imply just a change in velocity, not apply an acceleration. But that's not... Is that true? I guess at the end, since I just have constant gravity, then there actually shouldn't be an acceleration change. It's, like, more like an instantaneous acceleration change, which is an impulse. Okay, I agree with you. Okay, so we invert the y velocity after it hits the floor. we move it up so that it like only moved halfway through the amount that traveled into the floor, which I think also makes sense. And then we multiply its velocity by some like damping factor. So let's like try 0.9 for now. And let's see if we see like a bouncing ball. Let's see. Wow, it doesn't like that at all. So first of all, we shouldn't be checking 0. We should be checking if less than ball radius. This would be ball is positive y over 2. Okay, I think that's right. Okay, there we go. Wait, that's a bouncing ball. I don't know why it's not. It's getting to 0. Something about this doesn't feel right. I guess we'll say here, we'll drop it again if the ball velocity is like really close to 0. We'll reset it. Self ball y is equal to the ball start y, so we can at least see it happening again. It doesn't like that because math has no abs. That's crazy. Does that work? Oh, okay, so yeah, why is it bouncing? It doesn't feel like it's bouncing. Oh, it bounces when the bottom hits, but then it doesn't push itself back out enough. So we need to make sure that the ball position is at least the radius. Yeah. So at least it's 1 radius above the surface. Okay. That did something. It's not resetting though. Why is it not resetting? If the ball y is less than... Oh, I guess we'll just do this here. Outside of this if. That'll probably reset it nicely. And then self ball y velocity 0, 0. I guess we do this here. Boom, 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 boom. Okay, reset. Why is this never triggering? Stood, debug, print, y velocity. You're saying it's minimum radius, but it shouldn't, like the velocity is not minimized to radius, right? Just the position is. So the y velocity should approach a really fucking small number. Oh, because it's after acceleration. The acceleration is being applied every frame. Which is kind of what we were talking about earlier. So here you're saying, somebody was saying that we should apply all of our acceleration stuff after all of this. Which might make this a little easier to calculate, at least for this case. No. How do I, let's see. I guess we want to say if the ball didn't move. Maybe that makes more sense. Let's try that. So we'll say self ball y. This is the start y. Yeah. And then we'll say if the ball position abs self y ball start y minus the current y is less than 0.01. If it didn't move that much, we reset. He doesn't like that. Because I called it start Y, not ball start Y. Okay. Oh, oops, there's two. Okay, yeah. We'll call this frame start Y. Yeah. Except the threshold's way too large. Let's try that. Let's try that. Okay, there we go. There we go. It's like a little nice little bouncing ball. We did something, guys. We did something. The worst physics system of all time. But it's something. Can we make, like, I want it to bounce more. Is it really such a large bouncy value? Even 0.99 is triggering such a small bounce. Am I doing something stupid? Negative 0.1? Oh, because gravity is applying immediately. I see. Okay. Sure. Good enough for now. Okay, that's like decent progress for the day. It's not great. We don't have, we're not super far. We only have collision with like the ground, which is one item. Eventually, we're gonna have to like adjust this so that it can collide with objects, but I think that we will call that a task for tomorrow. So what did we do today? We constructed our like shitty little application. We serve a ball position through some HTTP server. We wrote a little web page to render the ball position in an HTML canvas. That ball is now having some rudimentary physics applied to it. And that is being rendered here at some frame rate. Yeah, okay. That's pretty good. Good progress for the day. So I'm happy with that. If you guys like what you saw, we stream most days at around 2 o'clock Pacific time. Right now, we are working on this Rube Goldberg machine, but there's other stuff on YouTube if you haven't seen it. So this is all organized in playlists under the there's a link in the Twitch description. There's a GitHub link in the Twitch description where this stuff will end up eventually. Maybe not today, but soon we will get this all up there. And yeah, we'll be back at it tomorrow around 2 Pacific time. If you're watching on YouTube, there should be a Twitch link in the YouTube description where you can swing by and say hi if you're online between 2 and 4 o'clock Pacific time. Other than that, I guess we have to say that you guys should like, subscribe, and Twitch Prime. Oh, I missed a Twitch Prime actually earlier today. Thank you, Minikin. And I think that's it. Bye YouTube and Twitch. Let's figure out who to raid.